So here is section 5.2, exercise 42. And they give us a differential equation with an initial condition. So we're told dy dx is x minus 2 over x, and at minus 1 we get 0. So I just want to get this antiderivative, and so I have x minus 2 over x dx, and well, I'm going to write that as 1 minus 2 over x dx, and so then that is, oops, now I'm doing the antiderivative. I get x and minus 2 log absolute value of x plus an arbitrary constant. And so with that, I can plug in my -1 and I get 0. So here I should have y is equal to, so I get 0 is equal to -1 minus 2 natural log of the absolute value of -1 plus c, and absolute value of -1 is 1, log of 1 is 0, and so we just get 0 is equal to -1 plus c, so c is equal to 1, and that says our function with this initial condition is y equals x minus 2 natural log absolute value of x plus 1. And so, if we want any other functions, we can always just change our value of c. So I could have y equals x, well, call it y1 or something like that, x minus 2 log absolute value of x plus 5. And I could have y2 equals x minus 2 log absolute value of x minus 6. Okay, so I could have those. Now let's look at plotting it, because it asks you to plot this stuff. Now again, I like to point out, okay, so I just defined a function f of x as x minus 2 over x, and I evaluated, I created its antiderivative, a particular antiderivative, by letting this lower limit be -1, because then I know that f, big F of -1 is 0, because it starts at -1. Now, the problem with that is that, this is my, get rid of that for a moment. This is my function in black here, but it only did one side of 0, because that antiderivative, if you write it in this form, like the second fundamental theorem of calculus, you can't have the function go past a discontinuity like this one that we have at 0, because little f of x is not defined at 0, and it's a very nasty discontinuity here. So so it gets stuck. And if I plot our answer, so let me call that, I could just call it y, I guess. Y equals x minus, what was it, 2, I think, 2 natural log of the absolute value of x, like that, and then plus 1. Okay, and we see that the red function is the same as the black function, except um, we also have that right-hand side of 0. And then again, I could plot the others, simply by, y, and I could call it y1 equals x minus 2 log absolute value of x plus, what did I say, 5, I think, before. So that puts a function up above, and I can plot, something else with a different constant. There we have exercise 42.